Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about Bayes theorem. The Bayes theorem, we are going to discuss about statement of the Bayes theorem and the problems related to Bayes theorem. Statement of the Bayes theorem. Here we are noticing a circle and the outside is the capital S is there. This capital S denotes sample space. That is, it is a set. The total, all the events, what it contains, that is, everything it is included in this sample space. E1, E2, E3, so on, En. So, E1, E2, E3, so on, that is up to, so on, En. These are the events which are included in this sample space. Sample space, it's nothing but, it is a big, all the outcomes which are included in this sample space. One more event it is there, that event name we kept capital A. So the name of this event is capital A. This capital A, which is interacting with E1, interacting with E2, and interacting with E3, and so on up to En. And one more condition, this E1 and E2, these two events, they don't have any common points. And E1, E3 also, they don't have any common points. Now, what it is explained in this diagram, same it is written now, E1, E2, so on, En are N mutually exclusive. Here it is N mutually exclusive. That is the reason E1, E2, E3, so on, En. So N mutually exclusive. The meaning is E1 and E2, they don't have any common. That's what we can call it as disjoint events also we can call. And exhaustive events. That is, this entire S, the sample space which contains E1, E2 up to N events it contains. That is the reason it is exhaustive events. That is, all the total events are, it is in sample space. So, exhaustive events. And this meaning of P of EI, it's nothing but probability of EI, where this I is taking the values 1, 2, up to N. That is, from 1 onwards up to N it is taking. That is what in the diagram also E1, E2, E3 up to En it is written, and the probability of each event is greater than 0. That is, it is positive. Mathematically greater than 0, the meaning is it is positive. And the sample space, everything it is there in the sample space. And already I explained this one more event A, it is there in the sample space, that event which is interacting with all the events. That is the reason here A is another event in S which is intersecting with every EI. With every EI in the sense our I is nothing but it takes the values from 1 to n. Now you can see it here also. A can occur in combination with any one of the events E1, E2, so on En, such that probability of A greater than 0. The meaning is even this event A which is intersecting with our E1, E2, E3, so on En, that event probability of A which is also positive. So if all these conditions are satisfied, then probability of E1, probability of E2 up to probability of En, it's nothing but probability of A given E1, probability of A given E2, probability of A given E3 up to probability of A given En. Then we can define this Bayes theorem formula. E probability of Ek given A, it's nothing but probability of Ek into probability of A given Ek divided by all the events, main events. In the statement, main events are E1, E2, up to En. All the main events into this intersecting in event. And this is nothing but the event which is coming intersecting with our main event. This is the way the Bayes theorem formula which is framed. Now, using this formula, we are going to in detail taking the problem, we are going to discuss and we are going to solve the problem. A businessman goes to the hotel X, Y and Z. 20%, 50%, 30% of the time respectively. It is known that 5%, 4%, 8% of the rooms in XYZ hotels having faulty plumbing. First, we will understand what is the meaning of this given problem. Now, a businessman is there. He is going to the hotel. The hotel names X one hotel, Y another hotel, Z is the third hotel. He is spending the time in X hotel 20% the time he is spending, whereas Y hotel 50% he is spending. Coming to the third one, 30% he is spending. Fine. Now, according to Bayes theorem, we know it. So, reading this question itself, we have come to a conclusion that this X, Y, Z are the main events. Fine. Now, one more event should come. That event should intersect with our main events. That is the basic concept of our Bayes theorem. Yes. What is that event which is coming and interacting with our main events? That is nothing but even our main events are X, Y, Z. In the main events, those hotels, all the rooms, some faulty plumbing. The plumbing work, some problems are there. Got it? X. So the faulty plumbing, which we are going to name it as one event. We are going to name it as one event. That event name, it is our own liberty, freedom. We can name it any one capital letter. Clear? Yes. Now, that event which is intersecting with our X, how much percentage? 5. Y, 4%, Z, 8%. So this is the meaning of the question. More it is there. What is the probability that the businessman's room having faulty plumbing which is assigned to the hotel? That is the total probability of faulty plumbing in all the 3 hotels they are telling us to find. And especially they are asking, what about Z? So that we are going to discuss in detail. Yeah, we can see it now. So if this is the way, the whatever the question it is given, if we are able to put it in the picturization, we can avoid the careless mistakes. Now sample space is there. In the sample space, what are the main events? Yeah, reading the question easily we can tell our main events are X, Y, Z. Yeah, it's fine. One more event. So that is very, very important event. With that only Bayes theorem, the given problem comes under Bayes theorem. So if you are reading the question, there is no word Bayes. It is not at all mentioned. The students, they should be in a position to identify whether the given problem comes under Bayes or not. This is the way this picturization, when reading the question, we are able to put in, then we can come to a conclusion that the given problem comes under Bayes theorem. Now this capital E, it's nothing but there's a faulty plumbing. The faulty plumbing, that we have given the event, the name is E. This E is intersecting with our X. How much percentage? 5%. With the Y, it is 4%. With the Z, it is intersecting with 8%. Clear? So this is main event, intersecting event, how they are intersecting with the main events, that it is possible to, we are able to design it, then this problem comes under Bayes and we can forward further. Yeah, X, how much percentage? Main event, 20%. Y is 50%. And Z is 30%. In the question, now we explained, and reading the question, we put a diagram also, and in the diagram also, we plotted everything. Okay, we will solve the problem now. Yes, this is, if you're noticing, the complete problem, it is not written. Only the main event regarding what is the sentence, it is there in the question, it is kept here. That is, a businessman goes to the hotels. They are X, Y, Z. For X, what is the time he is spending? He is spending 20%. What about Y? 50%. And the last one, Z, he is spending 30%. He is spending. Fine. This is the main events regarding that probability we are going to write. That is step 1. Step 1. Let X, Y, Z be the hotels. That businessman goes to the hotel. The probability of the main events, that is according to our problem. This problem, our main events names are X, Y, Z. X, Y, Z. This problem to problem differs. This particular problem, X, Y, Z. Yeah, probability of X. It's nothing but, we can see it. This is the 20%. 20% given. That is what? 20 by 100. Simplification we did. We got it 1 by 5. Next, probability of Y. It's nothing but 50%. So the 50 by 100 equal to 1 by 2. We got it. The last one is P of Z. So the P of Z, it's nothing but 30%, which is given here. So 30 by 100, the lowest form, the lowest fraction form, we brought it. So 3 by 10. So from here, we are understanding very clearly that the step 1, which is common for every problem, every Bayes problem, step 1, we will write about main events probability. That's all. We are defining step 1. First, we will check whether the problem comes under Bayes or not. Second, when we are solving the step 1, it is taking the role of main events probability. So we completed the questions some part, that is some part in the sense regarding main events that regarding the sentences which are listed here, and we solved also the step 1. Now we will move to step 2. Yeah, step 1 actually, the diagram also which is kept here. You can see it. Yeah, this is the step 1 diagram. Yeah, now we can see it. The question, the before slide up to here, from here to here, we regarding the main events, step 1, we explained it. Now the question, little bit we extended it. That is, we are finding step 2. We will be giving importance. One more event should come. That event is nothing but faulty plumbing. That event, we should give our own name. Here we are giving the name as capital E. This event should interact with our main events with some percentage. Yes, 5%, 4%, and 8%. That with this, we are going to solve the step 2. Yeah, we can see it. Yeah, yes is the sample space. These are the main events. Yeah, one more, that is what? Capital E, it's nothing but our faulty plumbing. We will solve it. So, let capital E be the event, that is the businessman staying in the hotel having faulty plumbing. So, we can see it in the small bracket which is written, which is intersecting, that is the faulty plumbing, the event name we have given as capital E, it should intersect with our main events, that is X, Y, Z. So, the students, when we are solving the problem, you must be in a position to write the step. When you are able to write, you are going in a correct path in solving the problem. This step we are not able to write, it gives an indication that we selected the problem. The problem, it is not come under Bayes. It gives an indication. So the step 2, it's very, very important. When we are able to write this notation within the bracket, then we are going in a correct path. We can more forward the problem. Clear? Yeah, next. Yeah. This event, the what we have, the intersecting the event, the new event, the name what we have given is capital E, which is intersecting with our main event X. What percentage? It's nothing but 5%. So probability of E given X. This is how we will read. E given X. What percentage? 5%. So 5 by 100. The lowest form we put it 1 by 20. Then the E is intersecting with our Y. Here is there. How much percentage? It is given 4%. So 4%, it's nothing but 4 by 100. It's nothing but 1 by 25. The last one, our E should intersect with our capital Z. It's 8%. It's nothing but 8 by 100 equal to 2 by 25. So the step 2, it's a nothing but event should come, that we will give our own name. It should intersect with our main events at what percentage. That we will be solving in step 2. We solved also. Yeah, we can say it. The step 3. It's nothing but, so X, Y, Z. Yeah, this is the main events. This problem. Capital E is the intersecting event. So that step 1, step 2, step 1, this is related to this. Step 2, it is related to this. Both combining, that is total probability of faulty event, faulty plumbing, that will be there in step 3. So we can see it. Yeah. The total probability that the hotel rooms have faulty plumbing. It's nothing but here P of X, P of Y and P of Z. P of X, P of Y, P of Z. These 3 we solved in step 1. That is step 1 we did. And this step 2. With this help we did step 2. Both we will multiply and we will add. It's nothing but this probability of the event which is intersecting with our main events. That is only step 3. The datas, P of X it's nothing but 1 by 5. P of E given X is nothing but 1 by 20 plus P of Y it's nothing but 1 by 2. P of E given Y it's nothing but 1 by 25. P of Z it's nothing but 3 by 10. P of E by Z it's nothing but 2 by 25. So calculations we will do it. It's nothing but 1 by 100 and this is 1 by 50, 6 by 250. Here we have taken the LCM 500 and 1 into 5, 5 and 1 into 10 and 6 into 2, 12. The total answer we got 27 by 500. So this is the question. The first step, main event. Second step, what we completed, that is a new event that should intersect with our main events, that is capital E. Third step, it's nothing but probability of the new event, the total probability of new event, that is this capital E. So step 1, step 2, step 3. All the 3 events are common for every problem of Bayes. So first, we can check whether the problem comes under Bayes, then quickly we can solve all step 1, step 2, step 3. But step 4 onwards, what is the problem? Given condition we have to see. It differs problem to problem. How it differs? We can see it. So we can say here. So we completed up to here. We made it a step 1 we did. From here to here we did step 2. And here step 3 they didn't ask, but we did. So the reason is step 3 it is compulsory. If it is not asked also in the problem, we will do it. That which help us to avoid the careless mistakes. Step 3, it's nothing but the new event. You can see it. Yeah, sample space. These are the main events, that is related to step 1. Related to step 2, that is a faulty plumbing, that we have given the name capital E. Yeah. Actually, usually here one sentence should be there in the question. That is the total probability of faulty plumbing. It is not given, but we are finding. If it is not regarding this total probability of that event which is intersecting, if it is not given also, it is advisable we will do it in the step 3. Next, step 4 onwards, we will be according to the problem, it differs. That is here, what is the step 4? What is the probability that businessman's room having faulty plumbing which is assigned to Hotel Z? That is, main events are 3 are there, but they are asking only about Z. They didn't ask about X and Y. So what is the question asked? Only we will do that and we will stop the problem. Here they asked only Z. How many? The total probability of faulty plumbing it has. So we have to solve now Z. So the total, so the probability that Z hotel room having faulty plumbing. This is the base formula, that is P of Z given E, which is equal to P of E by Z into P of Z. Clear? Divided by our main events all will play a role, and it's nothing but X is our main, Y is our main, Z is our main. So it's nothing but we can say step 3 already we found the value. That is the reason I told if it is not asked in the question also, step 1, step 2, step 3, we will make it common for all the base problems, which will give really no careless mistakes will be occurring. Even while writing the exam also, when we are tension, sometimes it careless mistakes, we will go room for that. Totally we can avoid. Correct the follow of steps. Step 1, step 2, step 3. Step 4 onwards, according to the problem, the main events. Here X, Y, Z, 3 are there. They are asking only one main event. If they are asking two we will do. Suppose in case if they are asking all the main events we will be doing. This is the basic concept and solving the base problem. Now we can finish off this one. Now we substituted all the values. P of Z is nothing but 3 by 10. P of E by Z, it's nothing but 2 by 25 divided by the step 3 already we did. It is here the value is substituted, and 6 into here we can see it 3 by 10, 6 by 250, 27 by 500. It's a reciprocal up, 500 by 27. The 12 by 27, lowest form we have given 4 by 9. One more problem we will do it. In a factory, machine A produces 40% of the output and machine B produces 60% of the output. On the average, 9 items in 1000 produced by A are defective. And what about B? The B, out of 250, you can see it, 250, one item is defective. More it is their question. First, these 4 lines are there. In the 4 lines, we have to pick up first what is our main events. Yes, we picked it. That is machine A and machine B. These two are our main events, and their percentage also 40% and 60%. Clear? So we are very clear about the main events. Now one more event should come. What is that event? We will read the question once again. That is, if we are reading the question once again, here, the machine A, it is the output, the 1000 outputs are there. When the 1000 outputs are coming out, in that 9 items are defective. So here defective it is there. Even B also defective is there. The defective, we will take it as an event. We will give one name. So that event is intersecting with our machine A and with our machine B. So this problem is fit for Bayes theorem formula to apply. So more, what is the question is given? An item drawn at random from a day's output is defective. What is the probability that it was produced by A or B? That is, in this question, total we have our main events are 2. All the 2 they are asking. Complete they are asking. So we will solve this problem. Yes. Sample space A, B. Two events. They are the main events. Yes. This D, it's nothing but the defective that we named it as capital D. So this A is nothing but, seeing the question we can tell easily, 40%, and B is nothing but 60%, and D is the event, that is the defective. What is the machine A? It is producing the total outputs. In the total outputs, some are defective. Regarding A, what is the point it is given here? When the output A is producing 1000 output, when it produces, in that 9 are defective. Coming to B part, 250, 1 is defective. So that D is intersecting with the A and B in such a way. So we will solve it. Yes. Now first step 1. Step 1, clear picture we are about it, about main events probability, we will write it. Now we can see it. So our main events are A and B. A is 40%, B is 60%. So you can see it. Yeah, some part of the question which is kept the down, which make our understanding level more. So A is 40%, B is 60%. We will solve it. So let A and B be the events that machines they are producing the outputs. The probability of A and B. So the probability of A, it's nothing but 40%. So 40%, it's nothing but 40 by 100. The lowest form 4 by 10. More the lowest form we are giving, it's nothing but 2 by 5. Probability of B, it's 60%, 60 by 100, 6 by 10, it's nothing but 3 by 5. So we completed step 1 regarding our main events. That is only our step 1 we completed. Step 2. Step 2, the new event, that intersecting event. Here the intersecting events is the outputs are defective. So we can see it. This up to here we completed step 1. Now this we are going to do, it's nothing but step 2. It's our intersecting event with our main events. It's nothing, we have given the name D. D represents the defective outputs. So we can A, B, main events. D is our defective outputs. So we can let D be the event that the outputs are defective. Yeah, this only I told very clearly that a new event should intersect with our main events. When we are in a position to write this, we are going in a correct path in solving the problem. If we are not able to write this one, then we selected the problem under Bayes in a wrong way. It gives an indication to us. This is very, very important point to be noted. Yes. Now step 2. Step 2, probability of this D is intersecting with our A in what way? That is 1000 output. The items 9 are defective. So 9 by 1000, 0.009. The next one, probability of D given B, that is 1 by 250. That is 250 outputs are there. In that, one is defective. One item is defective. Such a way our D event is intersecting with our B. Here it is given very clearly. So that value is 0.004. Now we will move to step 3. Step 3, here only we can see it. Step 3, we know it very well. This is the total the probability of defective. It's nothing but main event is probability of A into probability of this D by A plus probability of B into probability of D by B. This is only our step 3. Step 3, it's nothing but these two are step 1. This now only you can see it. This is step 2. Step 3 is step 1 into step 2. Both we are multiplying and adding. We will see it now. Yes. Yes. Main events intersecting. Step 3. The total. That is the probability that the items produced are defective. So just now what it is explained. So it is here. That is P of A into P of D given A plus probability of B into probability of D given B. The values to be substituted in the particular places. So we substituted it. P of A, which we already calculated, and P of D given A, it's nothing but 0.009 plus P of the probability of B, that is a main event, 3 by 5 into probability of D given B, that's nothing but 0.004. So we can use the calculator and easily we can calculate it. So 2 by 5, it's nothing but 0.4 into 0.009 plus 3 by 5, it's nothing but 0.6 into 0.004. So this calculation, it's nothing 0.0036 and this calculation is 0.0024. So we will add it. So this is 0.006. So it's a very clear thing. The second problem also. First step we completed with the main events. Second step we completed with our intersecting event. Third step, the probability of this intersecting event. 3 steps, it's common for every Bayes problem. Step 4 onwards, according to the problem, the main events. Sometimes they will be asking regarding, now here 2 main events are there. They will ask only one event or sometimes they will ask all the events. We will see it. You can see it here. So this is we did step 1, we did step 2 and step 3, that is the total defective. Here 2 events are there. They are asking about main event A, how many defective outputs, the total output it is producing. A. The probability that the machine A produced are defective according to the Bayes theorem. We can see it. Probability of A given D equal to, very easy to remember, here A given D, compulsory this side, probability of D given A. Some, to remember purpose, some sort of technique we have to keep it in our mind, nothing wrong in it. So probability of D given A into probability of A. The down compulsory with all the main events will be written. This, it's nothing but our step 3. Already we found the value. Just we will substitute here. This is the way if the problems are solved. Definitely careless mistakes, it won't come at all. We want to give room for committing the errors at all. So 2 by 5 into 0.009. This already we calculated 0.006. So the final answer is 2 by 5, it's nothing but 0.4 and this is written as it is here. The calculations we did, we got it 0.6. So 2 events, about the one event they asked produced by A, what is the output of defective? The probability of that. We will see it. Yeah, this is a complete question. It has come out now. So, main two events, A also they asked, B also. Complete all the main. That is, in this particular problem, our main events are two main events. All the two main events, about that, they are asking the probability each. What is the defective output? So, to understanding, to more, this diagram it's kept in every slide. So, the probability that the machine, here it should come step 1, machine B should be here. Machine B produced or defective according to Bayes theorem. So, B given D. So, probability of B into probability of D given. I told clearly, here B given D, here D given B. This technique also you can remember. And the down part, it's very easy to remember. All the main events will be written. Main events in this particular problem, capital A and capital B. So, it's nothing but our step 3 will be there down. What all we calculated? So, 3 by 5 probability of B and probability of D given B, it's nothing but 0.004. The step 3 value is kept here, 0.006. The calculation part, 3 by 5, 0.6, and it is written as it is. We calculated and we got it 0.4. So, we completed. So, this one, step 1, our main events are there in this particular problem. Machine A and machine B. That is, machine A is 40%, machine B is 60%. We completed that only. This is our step 1. And one more event, that is a defective. The outputs, what it is produced, in that we are finding some defective items are there. That is the defective. That event name we kept it as D. This D, how it is intersecting with our A. When it produces 1000 items, 9 are defective. How it is intersecting with our B. When it is producing 250 items, 1 are defective. So, this is our step 2. Step 3, nothing but step 1 into step 2. Step 4, specifically they will be asking about our main events. Here, 2 main events. Step 4, about A, we did using the Bayes theorem. Step 5, about main event B, it is asked in this problem. That is only this one. Bayes theorem, it is easy to remember. B, we wanted our main event. So, the main event given that intersecting event. Like that, if remembering, it is very, very easy. Instead of remembering the variables A and B, like this remembering, main event given that intersecting event. Here, easy to remember the technique, a small technique, that here B given D, here it will come D given B into probability of B. The down, all the main events will play a role. So, like this checking and the particular values what we calculated, we have to substitute. So, this problem also we completed. So, the conclusion. The first, what we have to do it. Reading the problem, we must be in a position to identify whether the problem comes under Bayes or not. How to identify? Main events first we have to pick, and their probability, it will be given in the question only. Step 1, we will solve it. And the next point, one event that compulsory which will intersect with our main events. That event we have to pick. We can give our own name. Then that probability we should find. That is step 2. Step 3, that intersecting event, the probability we will find. These 3 are common for every Bayes problem. Step 4 onwards, regarding the main events, suppose the main events are, suppose 4 events are there. In the question, they which main events they are specifically they are asking that to be solved. This is the way, easy way we can solve the Bayes theorem using the problems. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.